Hello, this is Mark, a fourth grade teacher in Minnesota, here to give you a glimpse into the Minnesota Benchmark of the Week, 4.3.5.6. Use place value language to describe how to multiply a number by 10, 100, and 1000. In fourth grade, students are developing a really powerful idea in mathematics. Each place value is 10 times the value of the place to its right, the core of our base 10 system. And this benchmark really is asking students to use that understanding to apply orders of magnitude to their thinking. It's more than a trick, it's a deep place value reasoning and part of looking for and making use of structure. We multiply by a number. When you multiply by 10, each digit becomes 10 times its original value, 100 and 1000 and such. The digits don't change, but their place value does. So take an example, 457 times 100. The 4 is actually moving from the hundreds place to the 10,000s place. It's true mathematical structure and not something you have to memorize. Many students are taught just to add a 0 when multiplying by 10 or add two zeros for multiplying by 100. This creates several problems. They misplace digits when numbers already have zeros, they lose track of why the result is larger, they struggle later with decimals, and they don't understand what the number actually means. The biggest problem is this: they're missing a chance to understand orders of magnitude. The little graphic there on the right basically is the Powers of 10 movie from the 70s, and Morgan Freeman redid it about 20 years ago. And you've got basically all categories of science sort of live in an orders of magnitude area. So you've got microbiology, chemistry, quantum physics, you've got astronomy, and that goes for societal statistical math too. There's orders of magnitude with those, and every place has its home. We live in a world where information is measured by these powers of 10, megabytes, gigabytes, terabytes. So you understand that 1000 is 10 times bigger than 100 is kind of a big deal when you're making decisions. For example, if your smartphone's getting full, like my family has had happen recently, a single HD video might be about 1.5 gigabytes. A photo might be 4 megabytes. So you want to delete space, where are you going to spend your time cleaning up your phone? Remember, a gigabyte is 1,000 megabytes, so 1.5 gigabytes, 1,500 megabytes. So how many 4 megabyte photos would you have to delete to equal that 1.5 gigabyte video? About 375 photos. So if you got rid of just 3 videos, that'd be like 1,000 photos clean up. You can save yourself a lot of time just by looking at your videos. It's exactly the kind of real life orders of magnitudes thinking that students need, and it's kind of a big impact thing in lots of areas of life. Some instructional moves that'll help you meet this benchmark: use place value charts, physically slide digits, ask students what is each digit worth before and after, use some language frames, use base 10 drawings, use error analysis like which answer makes sense and why, and connect it to real world magnitude examples like storage, money, distances, and population.